that is from, gosh, middle school, maybe earlier. Whenever you started learning about what makes 96 or any numbers, do you guys remember how you factor a number? Do you know anything about a factor of 96?
Is it like 1 times 96?
So 1 times 96 is a factor pair, yes. Besides itself and 1, what also goes in the 96? How do you know 2 goes in the 96? Because it's even. So I'm going to start with 2. And I'm going to factor 96. Once I find my pencil. Oh, here it is. So I'm going to take 96 and I'm going to factor this to be 2 times 2 times 50 is 100. 48. Okay, that is one factor pair, but what I'm going to do when it says factor it completely is I'm going to find like all the prime numbers that make 96 when I multiply them together. It's kind of like finding the recipe for 96. So 2 is a prime number. I'm not going to do anything with that. I'm going to factor 48, which is not a prime number, further. What goes into 48? 6 and 4. What else? 2 and 24. 12 and 4. No. 12 and 4. Did we say 6 and 4?
Yeah.
6 and 8. 12. Yeah. Yeah. Okay. I'm going to do 2 and 24. But this 2, I don't forget about that 2. It is still one of those factors of 24 or of 48. I mean of 96. Okay, so then is 24 a prime number? No, so 24 factors further to what? 2 and 12. Okay, I'm going to bring down the other factors that I still used. And is 12 a prime? No, that's 2 and 6. And then is 6 prime? No. 2 and 3? So when I factor something out, if the other factor is not factored all the way, I keep going until I cannot factor down these numbers anymore. So if I asked you for the complete factorization for 96, you probably would not tell me 2 times 2 times 2 times 2 times 2 times 3. That's not what you'd say. You'd kind of combine that, and what would you say? You would say, well, it's 2 to the 5th times 3. That's why we have exponents, so we don't have to say 2 times 2 times 2 times 2 times 2 times 3. Okay? So that's complete factorization. Have you done that before? Yeah. So now we can do that with polynomials. We can. I'll just teach you how, or you should have learned in Algebra 1, but it's, been a year. So we're going to learn 2 methods of factoring today, 3 methods of factoring today, and we'll learn the 4th one tomorrow. This factoring flowchart should be handy when you are learning this until it is like set to long-term memory. This should be here in front of you. Should not be put away in your folder when you're doing your worksheet. This is what you do to factor. The very first thing that we always do, you always look to see if there is a GCF. Do you know what GCF means? Greatest common factor. Remember, factor is something that goes evenly into the number, and common means they both have it. So I'll go over how to do that. I'm just going over the steps right now. After you factor out a greatest common factor, then you have to count how many terms there are. Terms are separated by addition or subtraction. Terms are separated by addition or subtraction. So you have to see how many terms there are. And if it's 4 terms, then you will do something called factor by grouping, which I will show you how to do today. If there's 2 terms, then you will do something called factoring by difference of squares, which I will show you how to do today. If there's 3 terms, then you're going to do something called guess and check factoring, which I'll show you how to do tomorrow. So today we won't be doing 3 terms. We're just going to do 2 and 4 and GCF. After this, then you will check all binomials that are left for something called difference of squares, which again I will show you how to do. All right? So our examples are separated by what kind they are, but our homework is not. The homework's all mixed up. So we'll go through the examples quickly, then we'll try some that are mixed up. So the very first section, all of these are factor the GCF out. Factor out the GCF. So the first thing that you need to do is figure out if 14a and minus 7 have a common factor. So what I do is I underline each term. There's 2 of them. I underline them, and I say 14a and 7. What divides into both of those? 7 is the biggest thing that goes into both. So I'm going to divide 7 out of those. And what I mean by divide, I mean, do you guys know the distributive property we just did in our homework? What you're going to do is you're going to do undistributive property. I'm making that word up, but it works. Undistribute. So I'm going to make it look like a distributive property question before you multiplied it in. So I'm going to take that 7 and I'm going to pull it out in front of a parenthesis. And how many things am I taking it out of? How many terms? 2, so there will still be 2 terms inside the parenthesis. So once I divide 14a by 7, what do I get? 2a, and then minus, and then 7 divided by 7 is a 1. So doesn't it look like the kind that you would have to distribute in? Today we're doing factoring, which is undistributing. So this is the answer. But if you're not sure if you got it right, you could always check. By doing 7 times 2a, 14a, 7 times minus 1, minus 7. Is that the original question? Yay, I did it right. But this is the answer. That's what I'm looking for. So undistributed. The next one. Is there a greatest common factor with all the terms? So we're going to underline 10x to the 5th and 20x to the 3rd. 10 is a factor, but there's some variables as well. How many x's are in common? 3. So we're going to write 10, and then we're going to write x to the 3rd under both of these. We're going to take out the common stuff. We're going to undistribute the common stuff. So I put that in front of a parenthesis. And inside the parenthesis, since I divided it out of 2 things, there's going to be 2 terms left. My first term is 10 divided by 10, and x to the 5th, take away 3 of those x's. What's going to be left? X squared minus 2, right? And if you're not sure if you did it right, you could distribute back in and check. There is another rule that I ignored on the first one, but I'm going to go over right now. After you do GCF, then you have to see how many terms are left. How many terms are left for this one? Inside. Inside. 2. So the GCF doesn't count as a term, it's just on the inside. So since it's 2 terms, we go here and we do something called difference of squares, which I haven't taught you how to do, so this one won't have it, but I'll start telling you what to think about. When we think about difference of squares, you first check to see if it is subtraction. Is it subtraction?
No.
Okay. The second thing you check to see if everything is a perfect square. Is x squared a perfect square? Yes. Is 2 a perfect square, meaning something times itself equals 2? No. So if the answer is no to any of that, then you are done. If the answer is yes, you have to do something else, which I haven't taught you, so we're not doing it yet. But I'll teach it to you in the back. All right, question C. You have to decide if there is a greatest common factor. 108x and 72. Anybody have an idea? 36. Is that what everybody's idea was originally? You thought 9? Anybody think something else?
They're even. I said they're even. You could have done 2.
Exactly. You could have done 2. But what do I mean when I say greatest? The highest number. Now, you were really fast to pull out 36. I'm going to pretend he didn't say that yet. And we will do it. I'm going to pretend that Emmanuel yelled out 9. Okay? Thanks, Emmanuel. So, I'm going to show you what happens if you don't take out the greatest common factor, because this might happen to you. So I would encourage you to write this down, and then I'll show you, like, with the greatest common factor what it looks like. So let's say we take out 9. We put a 9 in front. 108 divided by 9 is 12x, and then 72 divided by 9 is 8. Well, you don't have to, you can start over. But what I want you to notice is, you see how 12 and 8 still have something in common. If you don't take out the greatest common factor, these still have stuff in common. Still have factors in common. So I'm trying to show you, this might happen. You might accidentally pick something that's not the greatest common factor. You always want to look at this stuff and say, hold on, there's still stuff in common. I didn't pick out the greatest. So now you could either take something else out, or you just start over. I'm going to start over. But I'm doing this so that you can see from my notes what we did wrong and then how to fix it. So now, Gage, what's the GCF?
36.
Okay, so now I'm going to take out 36. And we'll put that in front. And then when we put that in front, we divide 108 divided by 36 is 3x minus 2. So now I can see that 3x and 2 do not have anything in common. So you can tell the difference between not the GCF and yep, the GCF. If you need to use your calculator to start dividing this stuff faster, you can. All right, D. Let's underline all of our terms. How many are there? They're separated by plus or minus sign. 1, 2, and 3. And then we look at each of those terms and we say, what goes into all of those terms? 2 and an A. So 2A. We take that 2A and we put it outside of a parenthesis. So if I have 2A to the third and I get rid of a 2 and the A, how many A's are left over? So the 2 is gone. A squared, yeah, A squared. Then in the middle I have a plus 12 divided by 2 is 6. Then I've got A squared and B on top, but I just take out one of those A's. AB. And then minus, I have 14A divided by 2A, so 14 divided by 2 is 7. Get rid of that A and you just have the 7. And then how many terms are left? 3. Should be the same that we started with. 3. Did I teach you how to do 3s yet? Nope. So none of these will factor further if it's 3 left over. Not today. So this will be it. Example 2. These are called factor by grouping. I'm going to look at these and I'm going to say, what is my first step of factoring always, no matter what it is? What's my first step of factoring, no matter what? Is there a greatest common factor? Find the greatest common factor. So how many terms are we looking at? 4 of them. Is there a GCF with 3xy, 15x, 2y, and 10? No. So that, we just skip it if there isn't one. We just skip it. Now, how many terms are there? 4. So we're going to do something called factor by grouping. And factor by grouping happens when you group things in different ways and you factor your groups separately. To start, since this is brand new or a major review from like a year and a half ago, we're going to do groups of 2 and 2. There's other ways of grouping them, but to start, we're doing groups of 2 and 2. You have to have a plus sign in between the 2 parentheses. Mine was there, but I just made it bigger, so I'm emphasizing it to you. There's a plus sign there. Then what we're going to do is we're going to go through the factoring rules for the first parenthesis. In the first parenthesis, what is our factoring rules always, forever? What do we start with? Is there a GCF in 3xy and 15x?
Yes.
What is it? 3x. So out of these 2 terms, I'm going to factor out a 3x. I'll put that in front, and then I'm going to open a new parenthesis, and I have a y and a minus and a 5 left over. Then I bring down that plus sign. And I'm going to do the same thing. I'm going to factor 2y minus 10. So we look at this and we say, is there a GCF for 2y minus 10? What is it? Just 2. So we take that out. And now we have left over y minus 5. So now what I have is I have a new expression that is actually like 2 terms. And I just underlined those 2 terms. So what I'm going to do now is I'm going to see if there's a GCF for these 2 terms. I'm going to factor again with these new 2 terms. Is there something in common above my green line? Edwin? Exactly. The y minus 5 is common. So I'm going to factor out the y minus 5. I'm going to undistribute the y minus 5. So if I undistribute it, it goes in front, and then we open up a new parenthesis. So when I factor out that y minus 5, what is left over above that green line? 3x, and then above the other green line, plus 2. When you have 2 parentheses, or when you have binomials, 2 terms, you have to see if you can factor these further. It's called difference of squares. Still haven't taught it to you, so this is not going to work. But you ask yourself, is this subtraction? Is this subtraction?
Yeah.
Okay. Is y a perfect square? Because they would say y squared if it was. I mean, I can ask you the same question. Is 5 a perfect square? No. So this one cannot factor further. Same questions again. Is this subtraction? Then they can't factor further. We're done. Okay? Let's do the same thing again with B. Factor by grouping. So we see 4 groups here. We're going to put parentheses, but you have to have a plus sign in between. So I overemphasize my plus sign, but what I did with that negative sign, that minus sign, is I put it in the parentheses. So when you do your groups, it's like making it plus a negative. It goes in the parentheses. And then you look in your first group and you think about your very first step of factoring. Is there a GCF? Yes or no?
Yes.
What is it? 2a squared. So that comes out 2a squared. We have left over 8 divided by 2 is 4. And when I 8 to the third one, I've got 3 a's, and I take 2 of them out. Just 1 a left over. And then minus. And what happens when I have a 2a squared over a 2a squared when they're exactly the same number?
It's 1.
It becomes 1. It does not become 0. It becomes 1. Second parenthesis. GCF.
3.
Okay, so I heard 2 different answers. I only heard 2 pieces. Okay, 2 different answers. Somebody said negative. I want, we're looking ahead. What I'm going to want is I'm going to want the 2 red parentheses to be exactly the same. If I take out only a 3, then I'm going to have a negative 4 left over.
Oh, yeah, so.
Yeah. What did you say? I know you did, but then after that, you were like, no, it wasn't me. It was right, though. It was right. Because we want to change the signs. So you're going to take out a negative sign as well. So now that minus 3 comes down, and then I have 4a, and then this changes the sign to minus 1. Then I look at these as being 2 big terms. And what are we going to take out of these 2 terms? So we're doing the GCF again. That goes in front. And then the other parentheses, after you cancel out those 4a minus 1s, 2a squared minus 3. And then we're going to check to see if it's difference of squares, which I still haven't taught you how to do, but is 4 a perfect square?
Yeah.
Yes, it is. Is a perfect square? So this is not difference of squares. This one is subtraction. Is 2 a perfect square?
Yeah. Wait, no, sorry.
No, it's not. Something times itself is not 2. So then these are done. What is this difference of squares thing? Oh, let me answer that. Here's another question. All of these are called difference of squares. In all of these, they have subtraction. They have a perfect square minus a perfect square. If that happens, you will factor it as being 2 parentheses, 1 plus, 1 minus, with the exact same numbers in the first and the second spot. If this one's a squared, then this one's going to be a. It's like whatever you multiply together by itself to give you a squared would go there. These together are called conjugates. Conjugates. When you have the exact same binomial, but one is plus and one's minus in the middle, they're called conjugates. And when you multiply them together, like we did in our homework, like we did in our homework, when you multiply them together, conjugates, then the middle terms always cancel out, and that's why there's only 2 terms. Those are the conjugates. So to factor 16x squared minus 9, you first say, is it subtraction?
Yeah.
Is 16 a perfect square?
Yeah.
X squared?
Yeah.
Perfect square? 9 perfect square?
Yeah.
Okay, so then what we do is we do 2 parentheses. 1 is plus, 1 is minus. What times itself gives me 16x squared?
4x.
That goes in the first spot. What times itself gives me 9? 3 and 3. Then we check to make sure that none of these are still perfect square difference of squares. So this one right here cannot be a difference of squares. You know why? Do you know why? Because of the plus sign. Exactly. This one here is not a difference of squares. Do you know why? Is 4 a perfect square? Is x a perfect square? No, that's why. So these are done. Next one, B. Is it subtraction? Is 81 a perfect square? 25 perfect square? X squared a perfect square? So difference of squares. 1 plus, 1 minus. What times itself is 81? What times itself is 25, x to the 7? 5x. Then we go back through a second time. 9 plus 5x. Can that be difference of squares? Why not? Because it is not a difference. But also because x not squared. But the first thing that you just look for is it has to be subtraction. If it's not subtraction, you might as well not think further. How about this one? This one is subtraction. Is 9 a perfect square?
Yeah.
Is 5?
Yeah.
Okay, so then we're done. Do you think I really spend that much time looking at it? No, but you have to until you can just recognize that it's not a difference of squares anymore. How about C? Is it subtraction?
Yeah.
Is 4 a perfect square?
Yeah.
A squared?
Yeah.
1?
Yeah.
1 times 1 is 1. Perfect square. Difference of squares. 1 plus, 1 minus. Square root of 4a squared, 2a. Square root of 1, 1. Is 2a plus 1 a difference of squares?
No.
No. Is 2a minus 1? Why not?
Because the a is not squared.
Because the a is not squared. Or because the 2 is not squared. Right? Either. Either is fine. Both of those good answers. D. No. D is a difference of squares.
No.
Why not?
Because
Okay. Fine. Because it is not subtraction, it's not a difference of squares, you don't have to go any further. This is prime. What's a prime number? Only divisible by itself and 1. That's the only factors it has is 1 in itself. So the only time you'd write prime is if you couldn't factor anything. All right, example 4 is kind of like more like your homework where there's going to be multiple things happening on some of these. So help me out. Very first step, always. GCF, greatest common factor. Is there 1 for 10x squared minus 10y squared? 10. Let's take it out. We're left with x squared minus y squared. Inside, we have a binomial. When it's 2 terms, we look for difference of squares. Is it difference of squares?
Yes.
Yes. So then we bring down 10, and instead of x squared minus y squared, we make 2 parentheses, 1 plus, 1 minus. We'll have an x and a y, and an x and a y. Can x plus y, which is a binomial, go further? Is it a difference of squares? No. How about x minus y? It's minus, not squared. Okay. Then that is done. How about B? What is our first step? Is there a GCF? What is it? 4. 2 is a CF. But 4 is a GCF. Okay. 4, and then we have x squared minus 25 left over. We have 2 terms left. Is it subtraction?
Yeah.
Difference of squares.
Yeah.
So we bring down the 4, 2 parentheses, 1 plus, 1 minus, x and 5. And those go further. Why not? Not perfect squares, and the first one's addition. Skip C. Go to the second page. We're not going to do all of these. Let's look at 2. What's my first step? Is there a GCF? Do I quit? No, if there's no GCF, you just skip that step and look because there's still 2 terms. And if there's 2 terms, what do you look for? Two terms? When you look back on our first page, if it's 2 terms,
The difference is squared.
we're trying to see if it's a difference of squares. So is it subtraction?
Yeah.
Is x to the 4th a perfect square?
Yes.
A perfect square would be something that you multiply by itself to give you x to the fourth. What do you multiply by itself?
2.
2 times 2?
X to the
All right. So there's 1 plus, there's 1 minus. X to the second times x to the second gives us x to the fourth. Y to the second times y to the second gives us y to the fourth. So yes, perfect difference of squares. Now we look at it again. The first one, is this difference of squares?
No.
Why not? It's not difference, it's addition. Is this one difference of squares?
Yeah.
Okay? So the first one just comes down, as is. The second one now has to factor further. Just like we had to do with that 96, where we had to factor it further. So what multiplied by itself makes x squared? And then y squared. And we look at it again. X plus y. Is that a difference of squares? Is x minus y a difference of squares? So then this would be done. And let's look at 6. What is our first step? Is there a GCF? And all 4 terms. Okay. Then it is 4 terms. What do I do for 4 terms? Have grouped them. Yeah. So we're going to put parentheses around the first 2 and the last 2 and put a plus sign in between. What do we do with the first parenthesis? Is there a GCF of the first parenthesis? A. So let's take out the A. Left with x squared plus y. Bring down that plus sign. What is the GCF from the second parenthesis? Negative b. Excellent. So take out that negative b. I'll catch it. So we take out the negative and the b. We have x squared and then plus y. And then we say, we now have 2 big terms. What's the GCF of these 2 big terms that I've underlined?
Or no.
Messed up on your paper.
Yeah.
So then we have x squared plus y. And then what's left over when I remove the x squared plus y? A minus b. Are either of those difference of squares? No. So then that would be it. This is stuff that the more you do it, you're going to get really, really fast, and it's going to be easy, and it's going to be like your favorite thing that we do in here. And it's going to show up in like every chapter from now on as well. So we definitely want to get good at it. Every chapter from now on. The assignment is that worksheet number 1 that I just handed out. Worksheet number 1.